Hello, everyone. Okay, so I just wanted to make a video on uh, this C++ motion matching implementation I have added, and it took me quite a while to get this done. A lot of debugging, a lot of searching, and navigating through source code and trying to figure out how to add nodes to the anim graph. There's not too much information out there. I did find another gentleman's videos which were super helpful with creating anim nodes, and I actually found them after I'd figured out how to create them. Um, but I'll put his videos in the description. But anyways, I wanted to show you what I was doing. So I have a really simple motion matching setup here. So if I look in my character, I've just added some enhanced input features. I'm not going to go too much over this, but just added in being able to look, move, and jump. Very simple. And there's no components or anything. I just set up a stack mesh character with the skeleton, and then add spring arm component and the camera, and pretty much everything here is the same. So it's just your standard character. Don't need to add a trajectory component or anything in here, but you can. Uh, and so if we look over here, this is my blueprint that I made based off of the C++ implementation, just so I could visually see what was happening. But this is set up in the background, so it should be able to work regardless without this. But uh, these nodes here, I've just added in a motion matching node, a pose history node, and just linking that to the output pose. And I've put in a move database so I can move the character around, and a jump database for jumping. But just to be simple, I just add the move and then connected it to pose history. Now in the pose history, instead of adding a trajectory component, I just set this generate trajectory to be true. So it's generating the trajectory for the character. Um, and then I'm linking that to the output pose. But the cool thing here is this is actually all set up in C++, so these nodes are being added to the anim graph in C++ and linked together. So I'm going to show that next here. So if we open up Rider here, uh, and I'm just going to get the Explorer open here. Okay, so here I'm going to close off that. So we have this anim instance I've made as the header file, and I'm going to kind of go through and explain everything. And then we also have the C++ implementation of it. And also I want to open up the build for the game, because there was a couple things I had to add in here. Don't worry about blend stack, but if you want to use blend stack nodes, you got to add those in. You need anim graph runtime, blueprint graph, and I think anim graph, animation core, and then obviously we need we're gonna need, well, you can use motion warping if you want, but you're gonna definitely need the post search and post search editor in there as well. Chooser if you're gonna use chooser tables. I'll eventually add that in, but yeah, so those are some of the dependencies you're gonna have to need to add here. Okay, so let's go through this. So this is uEditor graph, which is the primary graph that's used to display the nodes. So I'm making a variable of uEditor graph and adding its include up here. And we are going to get the current anim graph from using this blueprint class. So I have that set up here. This is going to be the database that we're setting up. The schema, you can define the skeleton in there for the database. And then we are adding, okay, so there's two types of nodes for the anim graph. So you have the graph nodes, which are these uanim graph nodes, and they basically just give information about the nodes in the graph itself. But they also contain a runtime node, which is essentially what is going to be your actual node that's going to implement the motion matching at runtime. So these are kind of like a wrapper for your runtime nodes. And so you create the graph node, and then this one is the runtime node. And then, so that is for the motion matching, as we saw there. This one is for the pose history node. And then this is for the root node, which is going to be the resultant. So if we actually go back here, here's the motion matching, pose history, and then this is going to be your root node right here. And so let's go back here. This was just me fooling around blend stack stuff. And this was me trying to make sure there's no duplicates of the nodes, which I figured out. These are actually all the pins for the nodes to connect them together. So I have input, output for the pose history. Then I have generate trajectory pin, so I can set the generate trajectory to be true on it. Motion matching node pin for output, and then database pin, and then also the root node pin. So we're going to head over to the C++. All right, so here, what I'm actually doing is you can actually, if I open up my other anim instance that I was working on here before, that I was testing stuff out with, and we go, oh yeah, initialize post search database. So this is actually how you could create the database itself in C++ and then loop through and add your animations to the database. So this is a little bit more stuff that you could do if you want to implement that, and I can go over that later. But here I'm actually just getting a reference to the post search database I made. So if I go here, jump database, and go copy reference, and then that's going to give this out as a reference, and then you can just delete everything except for what's within the ticks and place that in, and that's going to load it. And then you got a valid database asset, and I did the same thing for my schema. I set that up in the editor. This is setting up the skeleton, so I'm just loading my skeleton the same way, adding the skeleton to the post search schema, then I'm adding the schema to the database. After that, in native initialize animation, now this might not be the best function to do this in. If somebody knows a better way of doing this, can you please let me know? But so far this has worked for me. So I'm calling this, and in here this is where I'm setting up all the nodes. So I'm checking if this has already been done. If not, if it has, it's going to return. And then what I'm doing is in your anim instance, you have an anim instance proxy that's stored in there, and you can get the anim blueprint from there. And in the anim blueprint, we are going to have these graphs. So there's actually a couple graphs that I was kind of confused about before, but if you go anim blueprint error function, there was, I think, Uber graph pages. So if you get the first index of this, I found out it actually gives you out the, let's open up, where did I put this? Here. It actually gives you the event graph. So that will give you the event graph, and then the function graphs is actually the anim graph. So at first I was actually making these nodes in here, and I had to figure out why that was happening. It's actually the function graphs we need in the first page. So it's kind of cool. So here I'm just checking if it's valid for the graph there. And then after that, this block of code right here, essentially what I'm doing is I am getting the nodes that are currently stored in the graph itself, and I'm just going over and checking to see if the node was already created. I was having some duplication stuff happening earlier, and it was driving me crazy, but essentially I was creating the nodes, but I'd have 2 or 3 or 4 of them like basically being duplicated, and I didn't want that. So what I've been doing here is actually I was just looping over, checking what nodes are in the graph, and then I'm checking is it a type of the node that we're trying to create and trying to cast it. If that works, then it's going to utilize this. If not, it's going to come down here and it's actually going to use this fgraph node creator. And this is part of the, if we open this up, this is going to be part of the ed graph, and you can check out in here and see all the functions that are associated with creating a graph and stuff. This is kind of actually how I figured out, just read through all this. So we're using the create node function here. So we're creating the graph node creator, then we are creating the node, and then we're finalizing it, and it's just making sure the node has been added properly. We're doing that for the motion matching graph node, the anim graph node, and then for the root is a little bit different because when you open up the anim graph, usually you have the output pose in here already. So it's usually already added to the graph. So what I'm doing is I'm just getting, I found out that it's the 0th index of the nodes that are already in the graph. So that's what I'm doing here, casting and getting the root node. Next, this was the next thing was that I was having issues with is figuring out how to associate the graph nodes with the runtime nodes. And I found this getFnode function. So this gets the runtime anim node that we template. So this is actually how I'm able to set up what we want to do with the motion matching. So here I am static casting it because if you use any other type of casting, it seems not to work. This might not be the best way to do it, but I had to convert from fanim node base into fanim node motion matching. And then once I got the runtime node, then now we can set the database to search. So put in my database from up above, doing the same thing for the post history, getting that and setting the generate trajectory to true. And that's going to be, if you look here, when you open it up, it's setting this variable to true. All right, so once that's all good, it's all set up. Those nodes are created and added. Then this is actually for positioning the nodes, so you can change where they start in the graph. And then, and I gotta move these around anyways. The next thing is setting up their pins. So if you use, if we go to, let's see, a graph, I'm trying to get a link. the graph nodes. Hold on a sec. UD graph node. Okay. So if we go in here, these are the graph nodes themselves. So this is the positioning. You can also set like the size of the nodes to be started with as well. You can, sorry, this might be a bit boring, but if you're really interested. Down here, you can there is options to create nodes and add nodes as well, I think, or is that an ed graph? Oh, it's still an ed graph. Anyways, you can add the nodes, but when you do create node, it automatically adds the node itself. And I noticed if you create an intermediate node, it creates a like custom node that's not associated with the struct itself, or with the node that we're looking for, like the motion matching node. It'll create a different type of node, and then you have to kind of add the pins yourself to that. But these ones, if you use the where was it? If you use this, the f graph node creator, then it gets essentially the proper node, and it's going to come with the pins already set up on it. So how I figured out how to add the pins is if you go, if we open up a notepad here, and this is actually how I figured out how to find a lot of this stuff, but you can copy the node and then paste in here. This is going to give you out information about the node, and so we can look and see all the different pins, their property names, the pin name as well, and you can see here pose. This is going to be your output pin. So in here I was able to find the names for them and where they link to, and reverse engineer it. And so if we come back here, I was able to use this find pin function and pass in the name of it. So this is assigning those pins. So you got source, pose, like I showed. Same with generate trajectory. So we can add that in here. So, oh wait, we can set the default object on there. So I'll show you this. So if we for the database pin, which is on the motion matching one, you're accessing the default object, and then you can set that to be the post search database. So they'll show up. But I found out this doesn't really do anything. It's just for show. Essentially, when you're setting the database to search here, this is actually going to act on the runtime node. And then this is also like setting the value to true. So this is if you have to pass in an object, this is a value. And then this is actually how you connect the nodes together with their links. So this is going to make a link from the motion matching node to the post history, from the output to the input. And then I'm finding the resultant pin, which is this. And I am going to make a link from the post history to that. So I'm creating these links here. After that, you want to call notify graph changed and modify the blueprint. And this is just saying that we've ran this code, don't want to run it again. And that is essentially it. So now if we go in, should be able to compile it and stuff, and it'll be fine. And then we can play and look around and move the character. There's only a few animations in here, But yeah, it's pretty nice. Thank you very much. And if you like the video, please like and subscribe.